All right, let's dive into one of the biggest, most mind-bending questions in all of physics. And it's this: why is gravity so incredibly, ridiculously weak? I mean, seriously, it's a puzzle that has scientists stumped, and the answer, well, the answer could literally change everything we think we know about reality.
Just think about this for a second. You can take a dinky little refrigerator magnet and use it to pick up a paperclip. That tiny magnet is completely overpowering the gravitational pull of the entire Earth. It's something you see every day, but for a physicist, that's not just a party trick. That's a giant blinking clue that gravity is playing a totally different game than all the other forces in the universe. So what's its secret?
Okay, to really get a handle on just how much of an oddball gravity is, you have to see it lined up with the other fundamental forces.
I mean, just look at this chart. The numbers are staggering. Gravity isn't just a little bit weaker. It's weaker by a factor with 38 zeros after it. Physicists call this the hierarchy problem, because honestly, there's no good reason for this enormous gap. This isn't some small rounding error, it's a fundamental chasm in our understanding of how the universe works.
But here's the cool part. Most physicists don't see this as a mistake in our math. They see it as the single biggest clue we have that our view of the universe, with its 3 dimensions of space and one of time, might just be the tip of the iceberg. It feels like gravity knows something the other forces don't, something about the real architecture of reality.
So, where do we look for answers? Well, our first major hint comes from one of the most famous and infamous ideas in physics: string theory.
The basic idea here is that if you zoom in on any particle, way, way down, you wouldn't see a point. You'd see a tiny vibrating loop of energy, a string. Everything, an electron, a photon, you name it, is just a different note being played by one of these strings. And what's really beautiful is that one of these notes, one specific vibration, perfectly matches the properties of the graviton, the particle that carries gravity, but it also reveals a huge difference in the shape of that string.
So according to the theory, most particles, all the stuff that makes up you, me, and the stars, are open strings. Picture a little string with 2 ends. Those ends are stuck. They're anchored to the fabric of our universe. This basically traps them here. They can't go anywhere else.
But gravity is different. The graviton is a closed string. It's a complete loop. It has no ends to tie it down. And this is the whole shebang, the core idea. Because it isn't anchored. It's not stuck here with the rest of us. It's free to travel. It can escape.
So if gravity can escape, that immediately begs the question, where is it going? This forces us to completely rethink what our universe even is. And this leads us to the wild idea of Brane Cosmology. Stay with me here. The theory suggests our entire 3-dimensional universe is actually just a surface, what physicists call a brane, that's floating in a much larger, higher-dimensional space called the bulk. Think of our universe like a single slice of bread in an infinitely huge loaf. We can move all around our slice, but there's this whole other dimension, the rest of the loaf, that we can't get to.
And this picture explains everything so beautifully. We live on our 3-brane. All the particles and forces we know are stuck to it because they're open strings. But gravity, the closed string, can wander off the slice. It can leak out into the bulk. And this gives us a stunningly simple solution to our original mystery. Gravity feels weak to us because its strength is being diluted, spread out across these extra dimensions we can't even see. The consequences of this are just huge. I mean, if gravity can leak out of our universe, it might also give us a brand new way to think about another one of cosmology's biggest puzzles: why the universe is expanding faster and faster. See, the standard explanation is something called the cosmological constant, some kind of weird, dark energy that's pushing everything apart from the inside. But Brane Cosmology offers a totally different take. What if it's not a push from inside our universe at all? What if it's a gravitational pull from the outside, maybe from another massive brane, another universe floating nearby in the bulk and gently tugging on our own?
And this isn't just some hand-wavy idea. The theories predict that under extreme conditions, like near a black hole, gravity would really start to leak into the bulk in a big way. It wouldn't just be diluted, it would start acting in a way that truly reflects its access to this bigger, higher-dimensional reality.
Okay, I know, this all sounds like something straight out of science fiction. Parallel universes, leaking gravity, but the amazing thing is, physicists think they might actually be able to test it. So how on earth could you find evidence for a 5th dimension?
Well, we can't see into the bulk. Light is made of photons, and photons are open strings. They're stuck to our brain. But gravitational waves, They're ripples in space-time itself, carried by those freewheeling gravitons. And since gravitons can travel into the bulk, so can their waves. This means our best shot at finding extra dimensions isn't a telescope, it's a gravitational wave observatory like LIGO. We might be able to hear the echo of a fifth dimension.
The experiment is actually pretty straightforward in concept. When two black holes smash into each other, they unleash a titanic burst of energy in gravitational waves. Einstein's theory of general relativity gives us a super precise prediction for how strong that signal should be when it gets to us. But, and here's the key, if some of those gravitational waves leak into a fifth dimension on their way here, the signal we actually detect will be just a tiny bit weaker than predicted. We'd be looking for missing energy. That would be the smoking gun.
So, have we found anything? Well, the very first gravitational wave we ever detected, a signal called GW150914, was the perfect test case. And the result? It matched Einstein's predictions perfectly. Now that doesn't kill the theory, not at all. But it does tighten the screws, telling us that if there is a large extra dimension, it has to be smaller than a certain size.
But listen, the search is far from over. Every year, our detectors get more and more sensitive, and we're constantly sifting through the data looking for that one signal that's just a little bit off. The first time we see a gravitational wave that's even a fraction of a percent weaker than it should be, that would be one of the biggest discoveries in human history. It would be the first concrete evidence that our universe isn't all there is.
And that leaves us with one last, truly profound thought. If we're listening for gravity leaking out of our universe, what about gravity leaking in? Could that mysterious force we call dark matter, that invisible stuff that seems to be holding our galaxies together, be nothing more than the gravitational shadow of ordinary matter on a parallel brane floating right next to ours? It's a wild possibility, but it suggests the answers to our biggest mysteries might be hiding just next door, in a direction we can't even point to.